One night, a boy of height h is walking at a constant speed v0 along the edge of a straight horizontal sidewalk. Now, at a distance L from the edge of the sidewalk, there is a lamp post as shown in the figure, and the lamp is fixed at a height h above the ground. Now, as the boy walks, his shadow on the ground shifts continuously as well as changes its size. We have to find the velocity vector of tip of shadow of his head, and then we have to find the rate of change of shadow's length as a function of position x and y of the boy. Now, to analyze the shadow, let's understand this first. Suppose we make a line from here, this line. So this line and this lamppost will be perpendicular, and let's say this distance is y and this is L. So this side will be under root of y square plus L square. So rays will be coming something like this, and it will be passing, and somewhere it will be forming a shadow on this line. So to understand it better, let's draw a diagram in this plane itself, the plane of this lamppost and the man and this line. So here's the diagram. So this is our lamppost of height h, and then at a perpendicular distance of y square plus L square. So at a perpendicular distance of under root y square plus L square, there is a man of height small h. So we are drawing it in this plane. So these lines, this lamppost and this line is at 90 degree. So we are just drawing it here to understand it in a better way. So if we see the shadow of the light, so light is coming from the lamppost, passing over the head, and then coming at a distance somewhere on the ground. So let's try to find the distance of the shadow tip. Basically this entire region is a shadow region. So this is the tip of the shadow of head. So let's try to find this distance from the lamppost bottom or the base to the tip of the shadow. Let's assume this distance is S. Now from similar triangle we can write capital H divided by S is equal to small h divided by this distance. So this will be S minus under root y square plus L square. So using this we can get the result that h s minus h under root y square plus L square is equal to s small h. So s capital H minus small h is equal to capital H under root y square plus L square. So here we have s is equal to h divided by h minus h under root y square plus L square. So this is the distance of the tip of the shadow from the base of the lamp post. So if you look in this diagram, this distance as S. So this is the distance S. This was, suppose, angle theta, and this distance is nothing but y, and that was L. So from this triangle we can write tan theta is equal to y by L, and this distance was y square plus L square. So we can write cos theta as L divided by under root y square plus L square. Similarly, sin theta is equal to y divided by under root y square plus L square. Now if we see, this was the x-axis, this is the y-axis, and we know S is somewhere here. So the coordinate of tip of the shadow will be, this distance is S cos theta, and this it will be S sin theta. So the coordinate of shadow tip will be, in the x-axis it is S cos theta, comma S sin theta with proper signs. So we have the value of S as h by h minus h under root y square plus L square, and here we have cos theta is equal to L by this, sin theta is this. So the coordinate would be, instead of s we will write h by h minus h y square plus L square into cos theta, and cos theta is L by under root y square plus L square. So this will be L by under root y square plus L square, comma, the y coordinate is s sin theta, so it will be h by h minus h under root y square plus L square. This is s into sin theta, and sin theta is y divided by under root y square plus L square. So this gets cancelled, this gets cancelled. So we have the coordinates as h L divided by h minus h, comma, h y divided by h minus h. So if you see, the x coordinate is constant, hl by h minus h. So that means the x coordinate of the tip of the shadow is not changing. So the velocity of the head of the shadow will be only in y direction, and since this was the y coordinate, so velocity in y direction will be dy by dt. So the velocity will be dy by dt. So differentiating this term, we will get h divided by h minus h into dy by dt, and dy by dt is the speed with which the boy is walking. So we get h by h minus h into v naught. So this is the velocity of the tip of the shadow, and this will be in positive j direction, j cap. So this will be our answer for the first part. Now coming to the length of the shadow, we already have the value of s. So in this diagram we know this is the s. So the length of the shadow is s minus under root y square plus L square. So we can write length of the shadow is nothing but s was the total distance from the base of the lamppost to the tip of the shadow. So here, and the distance from man. So basically this is the shadow, this part. So the length of the shadow will be s minus under root y square plus L square. So we can write length of the shadow as s is h by h minus h under root y square plus L square minus under root y square plus L square. So length of the shadow is h by h minus h minus 1 into y square plus L square. So this will give us small h by h minus h under root y square plus L square. So this is the length of the shadow, and we have to find the rate at which it is changing. So d of ls by dt is equal to small h by h minus h. Differentiating this term, this is y square plus L square to the power half. So we will have half y square plus L square to the power minus half into differentiating this part. So this we have 2y into dy by dt. So 2 gets cancelled. Dy by dt is nothing but the velocity with which the boy is moving. So dls by dt is equal to h y v naught divided by h minus h into under root y square plus L square. So this is our final answer.